What's up, everybody? Welcome to 3.2 covalent and ionic bonds, but it's basically just covalent bond. Covalent bonds. So I'm going to be explaining a little bit about the ionic bonds because we've already kind of covered them in 3.1, but the rest of the lesson is going to be covalent bonds. So ionic bonds are bonds that form through two or more atoms, and one of them gives an electron to the other atom. Because they really want to get rid of the electron, right? So sodium is one of the alkali metals. They really want to get rid of the electron, so they get rid of the electron to chloride, who really wants the electron to be stable. And there's the stable rule is called the octet rule, and the octet rule states that valence shell of 8 electrons is the most stable. The exceptions are hydrogen and helium, right? Hydrogen and helium only need 2 valence electrons, and helium pretty much make compounds with no electrons because they already have their 2 valence electrons. So this octet rules allows the atoms to be in the most stable state, and even though these guys don't actually have it's an ionic bond, because one of the nothing's actually bonding them together. They're not sharing anything, but since they have opposite charges, they naturally attract each other. It's like a magnet, right? So positive charge, negative charge, they attract each other. And you write this as NaCl. You do not write it as Na plus Cl minus, because the plus a minus, a 1 plus charge plus a 1 minus charge is equal to 0. So there you go. There is another type of electron that don't want to give its electrons up so easily. They give the electron, they share the electron, but they don't give the electron. And the types of bonds happens when there is not enough or too many electrons between atoms. So for example, this hydrogen has 1, this hydrogen has 1, and the oxygen has 6. So if you combine them together, that's only 8. But the hydrogen needs 2, and oxygen needs 8. So you got to find a way to compromise with 12, right? 12 electrons. This status, in order to get 12 electrons, you got to share electrons, so that each atom can have the electrons that they need to become stable, right? So the water is a shared bond, and because they're a shared bond, it's a polar bond, and because it's a polar bond, it allows us to have life. But we're going to talk about that later. So you can see these two waters, and these two hydrogens, they have an electron each, so they share with the oxygen. Now the oxygen has a full 8 electrons, and the hydrogen has 2, and the other hydrogen also has 2. So then this is the structure, right? You use lines. I'm going to highlight it with a different color. I'm going to use lines for every 2 electrons that they share, and that's called a bond, right? A covalent bond. And the covalent bond share atoms. They don't take them away to form ions, so they're actually connected together. They're not like ionic bonds where they're attracted because of their opposite charges, right? So there's normally a central atom and surrounding atoms in these covalent bonds, and the central atom is normally the one that are covered by the other atoms because it's in the center of the atom, right? So if you want to make a Lewis dot structure, you have to do some math, right? So first of all, you count the electrons. 5 plus 1 plus 1 plus 1, which is 8. So there's 8 total electrons. 8 total, right? You put the hydrogens. So in this case, you put just the hydrogens around the nitrogen, because the central atom is normally written first. So we have N is written first. So N is right here. And H3, we put it around, right? And then you put the electrons around the central atoms. So now the central atom has 8, right? If there isn't enough, or if the other atoms need more, we're going to talk about that later. But we draw circles around, ensuring that each atom has the correct number of electrons, right? So we're going to try BF4 right now, BF4. So BF4 is, oh god, that is a terrible looking B. B, F, 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 the central atom's written in the middle, right? And how many electrons does this thing have? Well, it has, B is boron, so boron has 5, no, boron's the 5th, so it has 3. Plus, and then each fluorine is 7, so we go back, actually there's no periodic table here. Yeah, I'm just gonna have to remember. Hydrogen, helium, lithium, beryllium, and then boron. Right, so 31 total electrons. So 31 total electrons. But notice how there's a minus right here. I put BF4 minus, right? BF4 minus. So this is bromate, I think. And no, it's not. It's boron tetrafluoride. It's boron tetrafluoride ion, right? So there's a minus here. That means there's an extra electron. So it's 31 plus 1 is equal to 32, right? 32 electrons. 32 electrons. So then first of all, we put the electrons around the B. There you go. That satisfied the octet. We have 24 left. Let's put it around all the other ones because they also need 8. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 times 4 is 24. We are good. We've used all our electrons wisely. So our final diagram is going to be B, F, 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 F. We have our bonds, and then we have our outside electrons. And that's it. Okay, let's try our next one, next example. CH2O. CH2O, right? So this is a little bit more complicated because there's 3 electrons, but CH2. CH2, we're going to focus on the CH2 first, and then our O is just going to be our sideline, right? So C is in the middle, and then H right here, and then H is right here, and then O is right here, right? So first of all, what's the total amount of electrons? C has a total amount of valence electrons, right? Oh god, I'm sorry. Total amount of valence electrons. So in line 2, we have lithium, we have beryllium, and then we have boron, carbon, nitrogen, oxygen, right? So carbon has 4, and oxygen has 6, right? From last lesson. So we have 4 electrons from carbon and 6 electrons from oxygen, plus 1 plus 1. That gives us 12 total electrons, right? It only gives us 12 total electrons. But how many electrons do we need? We need, well, hydrogen needs 2, C needs 8, and oxygen needs 8. So that's a total of 20 that we need. 20 electrons we need, right? So first of all, we're gonna place the atoms around the center, right? There you go, simple, right? So now we have our H, C, H, and O. Where should the last 4 electrons go? Well, let's see. H, C, right, and then O. So how many electrons does oxygen need? Oxygen needs 8 electrons, right? We've already spent 8 out of the electrons, and oxygen has 2, right? So we put, if we remove these 2 right here, and then we put 2 more electrons right here, that'll form 4 electrons. They're sharing 4 electrons now, and you can do that in chemistry, right? And it's called a double bond. Now we'll have double bond, right? Double bonds represented by 2 lines. Oops, sorry. Double bonds represented by 2 lines. Oh god, this thing is connected with this. Damn. Yeah, you can form a double bond. Right, so now the oxygen has 4. The carbon has a total of 8 because, well, 2, 4, 6, 8, right? Carbon has a total of 8. So then we can place the rest of the electrons on the oxygen. So now oxygen has a total of 8 as well, right? Because we've only spent 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 electrons satisfy octet rule for all 4. For all 4 of these, right? And our final molecular structure is this. So our final molecular structure is H, C, H, O, 1, 2, 3, 4. That's our final molecular structure. And if it takes, it does take trial and error, right? Sometimes it takes trial and error, but this is our final molecular structure. Let's try C2H2. Now, since it's C2, there's basically 2 central atoms. So let's put the 2 central atoms, right? And then the H2, so we can just do this and then this. Once we get to molecular shapes, I will tell you why it's like that and it's not. I will tell you why it's not like this, even though like this is totally fine, right? If we're trying to do this, if you put it on top, it's totally fine, but it's just not preferred, right? So let's try C2H2. How many atoms do they need? How many electrons do they have? Well, they have 4 plus 4 plus 1 plus 1. That is 10. How many electrons do they need? They need 20. They need 20 electrons. So how many electrons need to be bonded? Well, 20 minus 10. Oh, sorry. 20 minus 10 is 10. Right? 10 electrons need to be in a bond so that both atoms can share it. But how many electrons do we have? We have 10 electrons. So all the electrons need to be in a bond. But how do we do that? All the electrons need to be in a bond, right? So first of all, we know that H only needs 2 electrons, so we can put our 2 electrons right there. And now these 2 C's, they're next to each other, right? They need to. This C already has 2 electrons. It needs 6 more. This C also already has 2 electrons. It needs 6 more to satisfy the octet rule. So we can just do 1, 2, 3, 4, 5, 6. Right? This will give us 1, 2, 3, and 4. And it satisfies the octet rule. So our final configuration, C, oh god, disgusting. C, H, 1, 1, 2, 3, 1. And that is the bonds of C2H2. Covalent bonds are stronger than ionic bonds because covalent bonds actually force the atoms to share them together, whereas ionic bonds just out of pure attraction. So if there's something that's more attractive, they will just break them apart. And that's how water breaks salt and nutrients for us to live, right? That's how water dissolves it, right? So that's going to be it for today's episode. If you like it, press the like button. And that's going to be it.